Well, hi folks. The last video I did, we talked about mapping notation and how to graph one of these sinusoidal curves. Um, but before we go on to part two of mapping notation, it's important to talk about the period of a sinusoidal curve. Okay? Remember, the period is the distance between which a curve like this where it starts over again. So the distance that it takes before it starts over. So with a sine curve, a regular old sine curve, and I'll use Desmos to show you here. There we go. A regular sine curve goes from 0, then it goes up, down, and right here. At 360, this thing starts over again to repeat the exact same thing as when it started. And I guess it doesn't matter what you call a starting point, but I just called 0 the starting point because I like 0 as a starting point. It's good. So using Desmos here, you can see that this pretty clearly. You can see that the period is 360. Watch what happens if I put a number in front of there, like 1/2. Whoops. Wow. Okay. So as you can see here, I put a 1/2 in front of x, and instead of 360, which is the usual period for a sine curve, the period is now actually longer. So you'd think 1/2 would make this period maybe half as long, but it does the opposite of what we think, because if you look closely here, it goes up, down, and back up again. At this point right here, where it starts over, is 720. That is doubled. So instead of 1/2, it's actually doubled the length of the period. Let's put a 2 here. If I put a 2 in front of here, look what happened. Instead of the period doubling, what happened is the period became, so we go up, down, and right here, this is the period, it's 180. So instead of doubling, it becomes half as much as the normal 360 degrees. Okay, so let's see, K, you can add a slider if you want to. When you adjust the period, the bigger the number, the higher the frequency, or the shorter the period we're going to have. Okay, and you can use Desmos to fool around with this. Let's move back to our normal little canvas here and just remind ourselves what we just saw. Okay, when we put a 2 where the x was, 2 in front of the x, the period halved. It became half as much. It became 180 degrees. Okay, the period became 180 degrees. A normal sine curve has a period of 360 degrees, and when we did a fraction like 1/2, instead of becoming half as much, it actually doubled to 720 degrees. Okay, so there's a formula that your textbook will show you, and it's period equals 360 over k. K being the number that's right in front of x. Wow, I just got a little advertisement in the bottom corner of my screen. That was annoying. So anyway, the k part is the coefficient in front of x. Okay, let's practice that right now. So here we cannot see any graphs at all. I can't see any of these graphs. I could graph them quickly in Desmos and figure out the period, but we're going to do the period without needing that. Okay, so in front of this x right here is a 1. Okay, there's a 1 there. So if we want to know the period is 360 divided by k. Now in this case, k is the value in front of x that's in the equation. In this case, it's 1. So the period is 360. And that makes sense because we just saw that on the other page. That's what the period is. The next question here, well, the period is 360 over, in this case, it's going to be a 2. Okay, 360 over 2 is 180 degrees. So the period is 180 degrees for this one. Okay, not bad. Okay, the next one here, C, the period is 360 over, look at that, 1/2. It's kind of awkward. We actually know what's going to happen because we just saw this on the other page, but 360 divided by 1/2, remember, whenever you're dividing a fraction, what you're actually doing is multiplying by the reciprocal of this, or flipping this thing. Okay, and that would be 720 degrees, which is exactly what we did get when we saw the actual graph. Okay, let's go back. Now we're doing, I believe we're looking at E. So 360 over, let's see, sorry, D. D has a 4 there. 360 divided by 4. Well, if you take a calculator, you can do it, but you'll see that the period will be 90 degrees. Do you see how with this formula, it's pretty quick just to tell what the period is if we're given the equation. You see how that works? Hopefully you're catching on to this. I am definitely doing enough examples, aren't I? Let's do the next one, E. What is the period here? Well, there's a 2 there, a 3 here, and a 1 there. We're only concerned with, when it comes to period, we're concerned with what's in front of x. So you put the 3 there, 360 divided by 3. Okay, and if you want to, you can take your calculator and just go 360 divided by 3, and you will quickly get 120. Or you can do it in your head, depending how your abilities are in your head. Okay, so the period's 120 degrees for that one. And last one, we have 1/3. Now if you remember before when we had 1/2, what we end up doing is multiplying by the reciprocal. So we're going to be multiplying, we're going to be taking 360 degrees and multiplying by 3. And that gives us 1080. And people that are skateboarders, they talk about this stuff all the time. So this is how you find the period when you're given the equation. Okay? An equation looks like all of these. And the front page here is how to find the period when you're given the actual graph. And it's just the distance to when the graph starts over again. Hopefully that's enough information to keep you going. Have a great day. And the next video is going to be on transformations of these things when we're dealing with the period. So hopefully you're watching these videos in order, otherwise it could get a little confusing. Good luck.